Well, I'm beginning with the window in the office where I work behind my desk, the archetypal timber sash window, which seems to be in the firing line when the discussion about the energy renovation of traditional buildings comes up. Usually single glazed and therefore considered to be very porous from the point of view of heat in a building. But of course, that window has shutters, which were closed at night or after dark. And that's practically makes them double glazing if we only remember that they're there and that this is a possibility for their use. So I'll be trying to be as practical as that in the discussion that I'm going to bring you on today. But it's going to start with the big picture. We're used to changing things bit by bit, and indeed that is almost a conservation principle. But in the last 2 years, we've experienced extraordinary step change in relation to COVID. We've all figured out how to work from home. We've accepted that a basic minimum income is not a bad idea, although I think we've stepped back from that now, and so on. We reduced our carbon emissions just by staying within our 5 kilometre zones as an extraordinary and unfortunately once-off step. I accept and believe that we're going to be experiencing step changes for the next 10, 15, 30 years, for the rest of our lives, as the various impacts of climate change affect us. So I think we're going to have to deal with innovation and questioning our presumptions and changing the way we do things quite a lot. So I'm going to give you a few examples from history and architectural history. This is a bridge just 6 miles upstream from Kilkenny City, and the next upstream crossing of the River Nore. And it was the prior version was swept away in a flood in 1763, and this one was built a few years later in stone to resist the type of flood that washed away the previous bridge. So we have things in our built environment that are inscribed sense, environmental sense, and they resist the worst that the climate or extreme weather events can throw at them. And we build things stronger as a result. As Shane pointed out, we also built things weak and flexible, and that in its own right is a strength. I won't overlap with the material in Shane's lecture, but there is a definite correlation. Here's a building in London, in Mayfair or South Kensington, with a beautiful conservatory, but it also has a toilet on the back, like many buildings around this square. And no buildings had toilets until the 1870s. There was no internal plumbing. It was something that a few mad landed country gentry did, and Queen Elizabeth did it as well, or something back in the 16th century. But it was the exception rather than the rule. Now, we can't imagine living in buildings that don't have toilets and sinks and wash-hand basins to begin with. So our buildings have experienced accommodated a wave of radical change since they were built. Certainly any building older than the mid-19th century. It's said that the architect Edwin Lutyens spent the last 10 or 15 years of his career retrofitting toilets into the grand country house extensions that he had been building in the prior period. If you're an architect, he's quite interesting because he didn't have corridors, he didn't like them, he didn't use them. So he had a series of rooms enfilade, maybe taking the full width of a building, and then along comes the problem of introducing plumbing. So he had to rethink a lot of what he was doing. Similarly, here's Roath House in County Kilkenny, in Kilkenny City. And I think for some people the most obvious thing that is a modification in this photograph is the reinforcement underneath the timber beams to make sure that they were strong enough for loads on the floor above. But again, if we think carefully and look at what we're seeing, this is a building that is now lit by electrical light. And again, electricity didn't exist in 1594, and it is impossible now to imagine a building not lit by electricity. There are a few exceptions, but they are extraordinary exceptions. Another wave of change that we've accepted in our buildings. Electricity is particularly interesting because it uses power, and power is what we're trying to reduce the use of in buildings. I'm going to take a more extreme example here. The National Gallery across the square, the subject of a recent, quite radical renovation. And I'm using this quote from Giuseppe de Lampedusa's novel *The Leopard*, where he talks about, for everything to stay the same, everything must change. And in the course of describing this change, the conservation architect at one point explained just how much was taken away in order to introduce the sophisticated mechanical and electrical systems needed to light these galleries perfectly and keep them at the right temperature. I don't have a picture of that, but I do have this picture of the service installation to describe just how enormous that intervention was. The sheer amount of machines that we now use in our buildings. Look around us. An air conditioning unit on the back wall. All of these spotlights in the ceiling. The projector. The escape lights, etc. Our buildings are now environments that are moulded by the energy that we put into them. And this wasn't the case. Shane mentioned, quoted the minister yesterday who was quoting an architect who said that the most environmentally benign building is the one that does not have to be built because it already exists. But buildings, when they were built at first, achieved comfort in an entirely different way, or perhaps didn't even aim at comfort. But people found ways to survive and stay warm and so on within them all the same. So I think we need this big picture, and I'll come back to why a little later in this talk. There are two aspects to climate change policy. I'm sure you're sick of hearing it. Adaptation and mitigation. Adaptation is where we accept that the climate is changing and we modify the things that we have, or we take care of things in a different way to ensure that they continue to survive. Mitigation is what we do to stop the climate changing. And that's where we talk about reducing energy use and all the rest of that, not cutting our bogs and so on. For an architect, or for someone who is concerned with a building, the two are kind of wrapped up together. Your gutters might leak more. You might find you have cement in your building and it's not necessarily doing it very well. And you're also being asked to reduce the energy use of the building and to achieve BER ratings and so on. And maybe you want to do that anyway because the bills are going up. So if we take it that the most important thing we need to do as a society, as a global community, is to reduce carbon emissions to the atmosphere, then we need to think carefully about what we're doing with our buildings. And I'm going to present a critique of the way that is being done in Ireland. I do so carefully and respectfully, because it's not entirely wrong. Our current policy is built around the objective building rating system, the building energy rating system, which requires that certain works be done and a certain software be used to model the building and demonstrate that it has become, at least in theory, more insulated and more efficient in the services that it contains. I fear that misses the point somewhat, and we know where buildings have achieved high BER ratings that they continue to use as much energy as they did before, because people take comfort literally from what they do. They walk around in t-shirts and shorts instead of 2 jumpers, a shirt and a vest. And we install more lights, or we don't count the lights that are plugged into the walls. We do count the ones that are hanging from the ceiling, etc. It's not necessarily a good measure of actual energy reduction. And I'll also be saying that the amount of material that we put into a building to achieve that BER rating also has a carbon cost. And if we install high intensity carbon insulation, PIR as it's called, PIR insulation, or anything that's metal at all, it's likely that before that machine arrives on your site and becomes part of the accountancy of BER, it has created emissions somewhere else in China in a factory, or even perhaps in King's Court in a factory. So I would like to consider the challenge of reducing carbon emissions to atmosphere by buildings, and look through some of those measures and government policies that are proposing to do that. I think that we, as people who perhaps care for older buildings, might wish to take a gentler approach, and I'm going to try and explain how that can be done. So we're presented with a dilemma, is the way I put it. First of all, strong pressure, especially for professionals, to conform with the building regulations, which usually means where major renovations are being carried out to achieve a BER B2 rating for the building. And that can have enormous consequences for the specification and for the sheer amount of stuff that has to be done to the building. On the other hand, I think there is an approach where we maintain the integrity of the building. We minimise our interference in it. We respect the embodied carbon that it contains, as well as its historic character and beauty. So that's the path I'd like to steer policy in, and I'd like to try and give you some advice, presuming you are building owners, about how we might get there, or what you might do at least at the start of that journey. I've done this myself. This is a building in Talbot's Inch in Kilkenny. I aimed at the 2006 standards for thermal insulation, which are way higher now. So one of the things I did was to do the mistake of locking in. I achieved an intermediate target of energy efficiency and U values and so on. And having done that and achieved it in 2005, there's no incentive for me then to, I'm not doing any building renovation works in the meantime. So the higher standard has then been set, and the event or the occasion for revisiting the fabric of the building and the works that you might do has not occurred. So this is performing below standard, below current standards now, because of the changes in the regulation. And there's an inertia with that. But that's another problem, and I'll try to show how I think that ought to be addressed later on in the talk. But to begin with, some simple principles and some simple observations. Protected structures and proposed protected structures are exempt from Part L of the building regulations. You don't actually have to do it all. But I don't think there's any client with expensive bills who wouldn't attempt to do something to achieve energy savings or to make their building energy efficient insofar as they can. I would like to see energy efficiency specifications not being at the expense of the character of buildings. This is a building built in 1911, renovated in 2002, 2005. So it was 94, 95, 96 years old at the time that it was being renovated. Current regulations and building construction practice in new build has a time horizon of 40, maybe 70 years. So it's assumed that a building built now is only going to last 40 to 70 years and then be replaced. And a whole series of decisions follow from that in terms of guarantees or the durability that's built into, or the obsolescence that is built into systems and materials that are being sold now. So what I would say is that a building that has lasted longer than 70 years has less to prove, because it is enduring and it retains the carbon that was invested in it at the time of its building. So I think we need to find a way to make that case. The fact that a building is in use now with modern services and machines means that it is using energy now, and that is a problem. We have to address that. So, some of the ways that we use energy in buildings, this is a vent pipe from someone's dryer, and we also don't heat our buildings and they become wet. This is a classic example, Shane, of a cement render on the outside of a building, which we now know is sealing in moisture, any moisture that is created in the building by human occupancy, by the installation of a shower, by a kettle, by a sink, by people breathing. I'll digress one moment on that subject. There was a dictionary of architecture published by a guy called Joseph Gwilt in Britain in 1847, an ominous year in Ireland, but he published a dictionary of architecture, and there's all about the styles that you could possibly build in. But one chapter was about materials, and he listed 23 materials, and 4 or 5 of them were different types of stone. So the palette of materials that a 19th century, let's say pre-industrial revolution, architect or builder had to deal with was minute, and in comparison to what we do now. And the interactions between those building materials were well understood. The most recent material that he mentioned was asphalt. And he said, the French in Paris, they're doing stuff with this material called asphalt. They're putting it on roofs. I think we should leave it alone for 70 years and see how they get on with that. Now, just contrast that with the way we think now about the UPVC window salesman. Anyone who puts plastic into a building, modified timber products, there's thousands and thousands of materials that are used in buildings, and none of them are tested by time. Now, I don't say that as a reason to not specify, it just means we need to take care. The cement here, cement invented in 1828, and without doubt considered by everyone who used it to be a superior material because it was harder and therefore presumed to last longer. And it took us 150 years to recognise the disadvantages in building of that approach before the defects that inevitably flowed from the use of too hard a material emerged. Just think about that. Shane mentioned problems that emerged with cementitious pointing in the 80s. The problems were built into our buildings as soon as we started using cement. But we didn't notice that. Nobody had the thought that this might not be a good idea. But it is worthwhile thinking like that if we do want our buildings to last another 100 or 200 years. If we do want to not make mistakes of investing in manufacturing the wrong materials now and pumping carbon into the atmosphere through that process with a view to saving carbon in the future. I heard a statistic recently, and this is just me listening to the news, and I'm not sure how correct it is, but I think the principle is correct. It was suggested to me that, I heard it on the radio, that in the last 35 years, we've put more carbon into the atmosphere than we did ever before as a species. Now, I remember 35 years ago, and I remember being concerned about global warming 35 years ago, and nothing we've done since has done anything to solve the problem. It's made it twice as bad. So I think we need to be careful and to think about what we're doing. I think it's merited. It's important. Building maintenance is the most basic thing. A wet building is going to lose more energy than a dry one. So I think that's been stated many times and it's obvious. But investing in the maintenance of buildings is a climate change strategy. Okay, taking care of the things that we have, making sure that they're dry, performing correctly. Here's a nice little diagram produced by Historic England that describes the difference between modern construction and older construction. The historic house is vapour permeable, air is moving through it quite freely, and with it moisture is being dispersed into the outside atmosphere quite freely. In the modern sealed construction, vapour gets concentrated. We're assuming that in both cases the same amount of water vapour is being generated within a house, but it has to be moved outside by deliberate action. The extractor fan, the strip on the window that provides ventilation, etc. And we do everything we can to prevent it from getting into the rising up the walls and so on by the introduction of damp-proof courses and damp-proof membranes. In the older building, we had a much freer approach to water vapour. Now, for a way to understand that, there's again another United Kingdom organisation, the Sustainable Traditional Building Alliance, which has really tried hard with the science of heat and older buildings and making the case for how good they are to begin with. And this is on the web, and I don't seriously expect anyone to grasp this. It's a toy, it's a tool. If you like going online and playing around with things, this is an interesting one. And what it does is it says if you take a measure, take a thing, a single thing that you might wish to do to a building or that someone might try to sell you. I think in this case it's a heat pump I've chosen, okay? And what the wheel does is it explains to you the other things about your building that you might need to look at simultaneously with that simple introduction, because buildings are complex and whole and integrated and interconnected. And a simple measure that you might take in relation to a building may have consequences in other aspects of the fabric. So this tool, which is freely available on the web and can be used quite seriously by designers or specifiers, is a very useful way, simply for my purposes, to visualize how complex buildings are. Okay? How complex they are technically. The archetypal image of how we can misunderstand buildings. I'm not sure if any of you lived in bedsit land at any point in your life. And very often heated with Super Sur gas heaters. Mm-hmm. And the mythology was that a Super Sur gas heater dried out the air. So the response to that mythology was to put a saucer of water on top of the gas heater. Now, nothing could be more misguided than to do that, because gas heaters turn whatever it is, methane and CO2 into moisture. So you were reinforcing and super loading the moisture content of the air in a room instead of doing what you thought you were doing. That's just a simple example of our misapprehensions about buildings, how buildings work, how they work technically. There's a phrase that you learn in architecture studio or when we're in school called architectonics, about how a building goes together and how the parts, the serviced and the served spaces, the beautiful parts and the pieces that make it work, how they all fit together. There's another word, tectonics, which is about how the materiality of a building works. And that we're in that realm now of needing to know how our buildings perform, how they exclude the weather, and yet create conditions in which we can feel comfortable. Did I say comfort? Jane Austen didn't use the word comfort in her novels. It wasn't a concept that existed. It was a newfangled thing that the Dutch invented maybe 50 or 70 years before. Buildings weren't built for comfort. You know the archetypal thing about seats and above the salt in a banqueting hall and all of this. Status was the most important thing that the interior of a building would deliver to its inhabitants, not comfort. Comfort was something you perhaps dealt with through the clothing that you wore. You didn't expect a building to provide you with comfort. There were moves that were made. People obviously lit fires and gathered around them. They had high-backed chairs to exclude drafts. They put soft furnishings, tapestries, canvases on the walls so that this radiant surface that your body was exposed to was not as absorbent of heat, and that changed the perception of comfort. So if you look into 17th century interiors and indeed 18th century interiors, you will see soft hangings and they provided an important dimension of comfort, but it was a soft version rather than demanding of the building structure that it do something to hold on to heat. Now, again, being a little bit practical, our building regulations contain a reference to an obscure piece of European standards, which costs €75 to buy, so nobody buys it. It's called ISEN 16883, Conservation of the Cultural Heritage, Guidelines for Improving the Energy Performance of Historic Buildings. Now, if anyone knew about this, it's actually a really great get-out clause for old buildings, and it's also actually very practical. At the centre of it is this process of thinking about an old building. And it's all very logical. There's nothing technically complicated about it. It's about what is the process that would lead you to a good result. So it talks about doing a survey of the building as the very first thing you need to do to understand what it is actually made from, perhaps how it has been extended and modified, and if that's different. It asks you to specify what exactly you're aiming for, and that might differ, for example, from one set of occupants to another. And describing those as targets. And then figuring out what you could do to your building. The obvious things are to add insulation in the attic, or indeed you might be pressurized by a salesman to think about insulating the external walls on the outside, or to install a heat pump, which is what the government are proposing these days as the panacea to many of the problems. What this suggests is that you take all of those and any others that the technical imagination can come up with that are practical, that could be applied to your building. So say, for example, in the case of the window that I began the lecture with, if that's not original, if it's a PVC window, for example, it might be appropriate to change that in its entirety and replace it with something that is more beautiful, more appropriate, and also performs better thermally. It might be appropriate to make the timber shutters work. There might be a whole basement full of grotty windows. That can be changed now and nobody's going to worry about it. To think about all of the measures that could be done to your building, and then to select them, to select the appropriate measures that are both practical and, let's say, affordable, but also minimize their impact on the character of the building. So just moving from compile a long list of measures to exclude inappropriate measures means generating choices and thinking strategically on behalf of your building, whether you're an architect or an owner or a building surveyor or an engineer. And that ability to choose and to select is where we can take care of the architectural heritage while simultaneously attempting to reduce our energy use and deliver our ethical obligation to not destroy the planet. And then those measures can be refined and put into action. So this asks, our building regulations, if you dig deep enough into them, require of us to think strategically, not to respond to the window salesman directly. I'm being pejorative, but I'm sorry, I'm just trying to be illustrative. Think, generate choices, and then select the choice. It's a kind of a basic management idea. It's what designers do. They make choices. It's what specifiers should do, to make appropriate choices in relation to a building. So, another piece of stuff from behind the firewalls. This is the British Standard 5250, Management of Moisture in Buildings, a code of practice for the management of moisture in buildings. And this is kind of circling down to what's really at issue in energy renovation of buildings. And this is a set of principles, and they're very practical and very technological as well to a small degree, as to what can and should be taken into account when looking at your building, a particular building. So, not to forget that walls facing in different directions might be doing different things, taking the context into account, that your building in Galway is different from your building in Dublin because of the weather, the gradient of rain and wind across the country. The condition of the building, how it is now, is critically important to understanding what can be done with it. Very often, buildings will display evidence of poor maintenance. And if a building has decayed or been degraded or damaged in parts of its fabric as a result of its experience over time, we can see what will inevitably need to be replaced. Perhaps it's part of the structure or part, let's say roof timbers are rotting. So now you have an opportunity to think carefully about what can be done to improve energy performance, as well as retaining or restoring the structural integrity of that building, and so on. The materials and constructions that it's built from, and the use to which it is put. Different users, different occupants in a building will place different stresses on the fabric, and so on. I'll go down. I won't go down through these principles now. They're a bit strange and wayward in this table, not fully self-explanatory, but we can think about them again. To put it in a nutshell, so this is, I call this the central mystery of a wonderful interior. It describes interior air quality, and that gets shorthanded into IAQ by the specialists. But it's a triangle of a moisture and heat balance. In fact, I've got that wrong. So there are three things that you want when you're sitting in your room. You want your air to be fresh and with the right amount of oxygen in it, and as little pollutants as possible. You want it to be at the right temperature, and you want it to contain, the building needs it to contain the right amount, or not to contain the wrong amounts of water vapor. Now, there's a bit of an art in keeping that balance, and it can be skewed. For example, again, the archetypal complaint of a building that conforms with the building regulations built in the last 40 years is that someone made the builder put a vent in the top corner of the room, and the first thing I did when I moved in was block it off because there was too much fresh air. So that's an example of how the three of these going out of balance undermines the regulatory intent or the design or specification intent of the moves to make the building comfortable. So we have to try and find a way of keeping these in balance. And the pressure from our climate policy is to use much less energy in making them warm. And we have nearly zero energy buildings as an aspiration. So that's what we need to think about if we want to make buildings, if we want to modify buildings to make them livable and use less energy. Okay, those three factors. And they're going to differ from case to case. It's an art of balancing from room to room, perhaps. Okay? And I'm an architect by training. I'm not a member of any institute. I focus on what I call specifiers, people who are entitled to or who have a professional ability to specify works for buildings and certify those works after they're done. When you look at a building responsibly and with those professional hats on, these are the three things that you need to do. If you, as a building owner, wish to take a look at making changes to your building on this basis, please be as informed as possible about these three factors and think about them together. The STBA wheel as a readily accessible web-based tool would help with that. So here's, I think, some relatively standard advice that is well understood at this stage in relation to roof insulation. Insulation that dramatically cools the temperature of air as it moves from interior to exterior can crystallize warm, moist air, and it turns into water in the insulation or beside the roof timbers, and it is vitally important for the functioning of the roof that the outer surface of the insulation has fresh air freely flowing over it, so that any such moisture can be carried away before it causes too much damage. So that's really important. And you see eaves, vents, and this is a proprietary product made out of plastic, never mind. But steps can be taken to ensure that ventilation gap is there. That's one of the basic things. Here's a section through that house that I showed you earlier as it began before it was modified. And this is what happened to it afterwards. Now, there's nothing necessarily legible in the drawing. Obviously, I suppose these days a huge big extension was built out the back. And it was comparatively easy to achieve the regulations through the materials and systems that were used there. I'll have to say from experience, bitter experience, that the junction between the two became a place of great draftiness. And that is an important thing to watch for and to consider in such renovations. There can be gaps like that, and they need just as much consideration as anything else. So minimum intervention based on understanding of the building, repair rather than replace wherever possible, care in the introduction of new materials, and then my own personal, there's a conservation principle which says changes should be reversible. In other words, in principle, you should be able to take the thing back again. I would prefer to replace that principle with one where you make changes that are additive. You make the building work by adding things to it. And if it's not necessary to take something away, if something doesn't prevent the building from working in the future, then leave it, because then it becomes evidence for the archaeologist in 500 years' time of how we used to live. Here's an example of how you might generate choices. This is a simple old-fashioned roof with no insulation that you might find. There probably wouldn't be a felt underlay in a very old building, but you might well have timber boarding. And then this is a way of thinking alternatively about how that roof could be modified. If, for example, you felt that the slating and the exterior were excellent or significant or had great value in terms of the historic value of the building, you would make your and of greater value than the interior, you might choose to make your changes from the inside, and so you leave everything on the outside the same as it was. You take off the ceiling and you put the insulation in from the inside, and you have to think through that. There are many things that need to be done. If, on the other hand, you have a beautiful ceiling just below your roof, you might want to make all the changes on the outside of the existing rafter and ceiling, and you have a different construction that has other implications. It might change the way the eaves works, or how the building abuts a parapet or a gable. And there's some intervening suggestions there as well. Perhaps you have important services above the ceiling, and yet you want to introduce changes. Without going into detail about any of those particular solutions, the point is to generate alternatives, to think about how you might do things in different ways, and then make a judgment, select the best, taking more and more factors into account. So in the case of the building I was showing you, the existing roof looked like this, and we figured, I don't have the detail there. We figured that the best way, the surface of the roof on the outside was a mansard roofed building, so a lot of slate visible. The first floor of the building was 2.8 metres high and the ground floor was 2.2 metres high. The roof was a big deal. It was meant to connote shelter. And there was windows in the roof and so on. It was arts and crafts style building. So the roof was really important, and the slate therefore was better left untouched. And on this coved section, where the rafters were only 5 inches, 125 millimetres in depth, what we did was we added a furring piece, added an extra piece of rafter on the underside that wasn't structural but provided space, and then fitted the boarded ceiling back on those, the underside of the newly introduced timber. So we got our thick insulation, the vapour gap above it, and the existing ceiling finish below it by thinking about it. And that's what that looked like in practice. So there's the old rafter and then a new extension, totally non-structural underneath it. Chicken wire to prevent the lime parging from dropping onto the insulation, etc. And then something I wouldn't recommend doing anymore, this is a foil-backed insulation for the dormers where there's very, very little space between the interior and the exterior to introduce an insulation layer. I'm not sure what I would do if I was tackling that now. So, next, when to think about energy renovation. I've borrowed this slide from SEAI. I hope if anyone is here from SEAI that they'll accept my gratitude for stealing our slide. But these are some observations about what they call, they have a behavioural economics unit. They want to understand how people think in order to, what would you say, make propositions to sell people, to sell things to people, sell ideas to people without encountering resistance. So they want to know how we think about renovation. People tend to stick with their current options unless prompted. Good enough choices. Crisis with the boiler, change the boiler, don't think about anything else. That type of thinking. We don't like risks and we don't like losses, especially most of us conservationists. We hate the concept of losing the character of a building. But as I've shown earlier, the character of Roath House would have been candlelit, but we don't do that. We accept that electricity is a definite benefit for it. People place too much emphasis on sunk costs. In the example I gave you, I renovated to the 2006 regulation standard. I don't feel like reinvesting to bring them up to the 2012 standards. People weigh future benefits less and present costs more. This is what has given us the climate crisis in the first place. We think in the short term. People use trust as a rule of thumb to judge risk. If they did it next door, and I like the people next door and I've been in conversation with them, then maybe I'll do it. Not necessarily a good indicator of risk. People's behaviour is influenced by the actions of others, and people overweight information that comes easily to mind. Anyway, listen, we could talk a lot about that. That's almost the psychology of the way we think about these things. We do need to take them into account. And then the times when the idea of energy renovation come to mind, there's one really important element missing in this diagram, and that is when there's a war in Ukraine and the Russians we start embargoing Russian energy supplies, which has had an overwhelming impact on the way we're thinking about energy in buildings. It's driven our energy production policy in the last 3 or 4 months. But we do think about it when we've experienced a bad winter, like say in 2009, 2010, when we're moving or selling or renting houses, when we're doing renovations, starting a family, retirement, and when we're making other repairs to our home anyway. So there are trigger points, and this is well understood, and it is important that when change is happening, make sure that the change is cross-complies, if you want, with the requirements to do things in relation to energy. And this is about how, well, I think it's more the marketing campaign of SEA, what helps people what incentivizes people to change their energy use. Energy audits, that's like the BER cert, or something that is more cyclical and repeatable. Setting energy saving goals, like I want to look at my bills for 2023 and see that I have used far less kilowatts than I did in 2022 or 2021. That's a very practical step that people can take. And it means, yes, changing your, what would we say? Putting in photovoltaic panels if you can afford to do it, and you can do so without damaging the fabric of your building. But it also means turning off the lights when you're not in a room, and perhaps turning down the dial on the heating system a little as well. So there are a few of the ideas about how people can be incentivized to use less energy. information flows, talking about it, feedback, is important. If it's a subject in conversation, then we're constantly reminded that this is something we should do. Oh yeah, I must go into the attic and turn off that light, the one that I left on when I was, etc., etc. This is a piece of kit that is used that helps sometimes to diagnose what is happening and is particularly relevant in existing buildings and maybe especially in old buildings. Carrying out an airtightness test by taking the door off its hinges and putting in this contraption and blowing air, I think sucking air out of the building and seeing where the drafts are, where the air is coming into the building. And that can be extremely useful. It's said that a typical old building has gaps the size of a football in it that can be stanched, and that helps because when the airtightness test door is taken away and the air is, when your normal door is put back and you're heating your building, they're the gaps through which hot air will expand and leave your building. So knowing where they are, and you can use smoke detectors or lighted tapers, special safety ones, to see where the drafts are and notice where they are. And then perhaps fit tight-fitting insulation, or indeed good old-fashioned plaster. I think there will be a huge amount that needs to be done with plastering as a simple and traditional airtightness improvement measure in existing buildings. On that subject, using that image, I'll refer to the course that we're about to run in the autumn in Limerick, which is a certificate in energy renovation for traditional buildings. We ran this before in 2019-2020. We'll be running it with substantially similar aims, quite a marked different content. And it's aimed at building work specifiers, architects, engineers, building surveyors, but also architectural conservation officers, BER assessors. It's going to be quite technical, but it will be open to come to. Yeah. Oh yeah, and one of the things, going back to those SEAI slides, SEAI recognise that the programme for renovating our existing building stock to make it more energy efficient needs what it calls trusted sources. And they don't call their trusted sources architects. They're thinking about one-stop shops, they're thinking about BER assessors, etc. But for renovation to work as a programme across the country, there needs to be people who understand what can be done and who accept the targets and ambitions and mediate between the targets and ambitions and where people are at with the buildings that they own, to figure out ways that the steps of the process can be put together. We've based our course on research that we did in 2017-2018, deep energy renovation of traditional buildings, assessing the knowledge gaps and addressing skills training in Ireland. We looked as widely as possible at the technical literature available, and that was done with ICOMOS Ireland and with Carrick Conservation International as well. Now, there are a series of technical guides that are available. The first one there, published by the Irish Georgian Society. I think it's available on their website. Lots of interesting essays that kind of cover this material in a slightly different way. These are the two, sorry, I should go back now. There's also a UCD study from about 2011. And the official government guidance from 2010 on energy efficiency in traditional buildings, that is being updated as we speak and intends to be a little more technical and more directed. And the Historic England version there, English Heritage, Energy Conservation in Traditional Buildings, SPAB, and another conference that the Irish Georgian Society was central to organising in 2017 on servicing in buildings. And I mentioned this the Sustainable Traditional Buildings Alliance. This is the start of a lot of the thinking about this subject. And yes, finally, I'm nearly finished now. The Irish Green Building Council have recommended what they call building renovation passports. It's a European idea, and in Ireland it's called, iBroad is one way that it is being done. iBroad is if you Google iBroad, you'll be able to find out a little more information. The concept is that, like a passport that tells you which countries you've been in, each building deserves to have documented the measures that have been taken to improve its energy efficiency and a plan for how that can be improved step by step into the future. And the wonderful concept behind this is that, well, first of all, that you document things. Secondly, that you make plans. But thirdly, that who you are, the occupant in the building, the occupants in the building are the starting point. Where they are in their life journey. Have you just got a house full of toddlers? Have you got teenagers? Are you retiring? Are you empty nesters? And so on. And all of those things will mean that the way you use energy in a building is different, and that the opportunities for investing further in the building or what types of measures you would take will be different. And then you might sell your building, and the next person comes in and wonders, why on earth did they do that? And there may be an explanation in the building renovation passport, and it may be possible to change directions for that building, but at least the journey of the building, its energy journey, is being documented, and that makes that bit of transparency can help. It can also help for the steps to be small and doable. I talked about step change, the enormous challenges that we're facing right at the start, but for each individual with a limited amount of funding, an outlook on life, they will have to be manageable steps for that individual. And so it has to be broken down again into small changes, and those changes are documented in the plan of the passport. Then you know where you're going. The other thing about the passport is that you can ensure that a step you take now is not one that has to be undone in the future. It's called avoiding lock-in, so that you make rational choices and strategic choices. Now, here's where I get a little bit critical. This is a heat pump, and there's been lots of disquiet for some of us just by the fact that this thing is made out of metal, and plastic, and this is the solution. We don't know how long they're going to last. My next door neighbour is a plumber, and he tells me that they leak. I look up on the website, and I discovered that there are these really funny little things that are the refrigerant. It's like a fridge, but working in reverse. It takes warmth from the air outside and puts it inside. So it's working like a fridge in reverse. And this stuff is called tetrafluoroethane. Tetrafluoroethane. And it has a global warming potential that is 1,430 times higher than CO2. Okay? Now, the scientists know this, and they're going to change the regulations, and they're going to get rid of these refrigerants in a few years' time when the regulations come into place. But if the 12 litres of tetrafluoroethane that is in your heat pump system gets out to the atmosphere, you might as well have been driving your car around for 5 years. So something that is part of the solution, in theory, becomes part of the problem. And I think we need to guard against that. That's a bit of the science from a website, insideclimatenews.org, from the 22nd of May, I think it was. Okay, if anyone wants to challenge me on that or look it up. This science may well be contentious. I'm inclined to believe it. My plumber next door neighbour tells me, you knock a pipe, it's gone, you have to replace it. But the it's gone part is 12 litres of multiplied by 1,400 and whatever it was, times the global warming potential gone to atmosphere now because of a measure we've taken which is entirely counterproductive. So I'd be guarding against the use of heat pumps. I think we really need to take these things into account. Now, I can't answer any questions on that if anyone is excited or bothered by it. That is, I'm outlining a position, and it's a sceptical one. So, our old buildings, some of them tragically in ruins as part of our landscape. This is the quote from 1997. The most environmentally benign building is the one that does not have to be built because it already exists. And it's what made me a conservation architect from being just an architect. I hated the smell of solvents on building sites. I couldn't stand the amount of steel that was looking around me. Couldn't be an environmentalist and specify all that stuff. But if you think just now about concrete and machines as well, to be an environmental architect, I think, means to make use of the buildings that we have. Okay? So reusing buildings is climate change mitigation. So thank you for that.